Okey, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So, pagi ni kita nak bincang tentang latihan yang saya bagi dekat you all dalam kelas tutorial semalam, semasa kelas tutorial semalam. So, saya berikan latihan, you can check with your answer betul ke, ataupun if you have any problem, you all boleh tanya saya. Okay, so let me share my screen first. Okay. Okay, so this is for question number 1. How we can solve this problem? Okay. Okay, maybe I can enlarge the question. Okay. Alright. Okay, so dia kata propane is a hydrocarbon gas that is commonly used as fuel for cooking. The standard enthalpy of combustion, that is the first information given. Standard mean it is for 1 mole. Okay, so this is the first information. Delta HC. Write the thermochemical equation for the combustion of propane. So how to write the thermochemical equation? Remember, thermochemical equation ada 3. Mesti ada balanced chemical equation, correct phase, and then the amount of the energy or energy that you refer to. Okay, so apa yang perlu ditulis adalah the reaction is between propane. Okay, propane gas. Kita dah tahu dah dia gas. C3H8 gas. Because it is a combustion, it undergoes reaction with oxygen, produce carbon dioxide and water. So how to balance the equation? We need 3 mole here. We need 4 mole here. And then oxygen, we have 3 darab 2, 6. 6 tambah 4, 10. So, kita ada 5. Kita nak 10, 5. And the delta HC is negative 2 to 0.1 kilojoule. Okay, so this is how we write the thermochemical equation. And this is the answer for point 1. Okay. Alright, so next, find the amount of heat released when 10 gram of propane combusted. So based on the equation, it is for 1 mole. If you only have 10 gram, how many mole? Right, so kita tulis nombor 2, nak yang kedua, soalan jawapan yang kedua. First, we need to find the number of mole propane. 10 gram over, you can find the molar mass of propane. I get 44. 12 darab 3 tambah 8. 44. Okay, and then you can get the number of mole, which is 0.227 mole of propane. Okay, so we want to calculate the heat release when 10 gram of propane combusted, which is 0.227 mole. So, to solve this problem, we need to write what we call it, perkadaran, something like that lah. 1 mole of propane combusted produce how much? Negative 220.1 kilojoule. If we only have 0.227 mole of propane combusted, how many mole? it's supposed to be larger or smaller than 220. Logically, it's supposed to be less than 220 lah, because the number of mole is less than 1 mole. Okay, 220.1. 49.96, because it is not, okay, negative 49.96 kilojoule. Right, so this is not the way to write the final answer. So you kata heat release, heat Q, because it is not at 1 mole. Bila kita dah sebut release, then you can put 49.96 kilojoule. Kilojoule, bukan kilojoule per mole, because it is not at 1 mole. Okay, negative sign indicate the heat release. Whether you put a negative or you write a statement, dua-dua boleh diterima. Okay, so this is the answer for number 2. Okay. Calculate the mass of propane required to boil 50.0 ml of water with the original temperature, with the initial temperature 30 degrees Celsius. Remember, required to boil. What is the temperature for boiling water? And state your assumption. Okay, soalan assumption yang atas tu cancel. Saya tertarik 2 kali tu. Okay, so apa maknanya? Okay, the process is something like this lah. Maknanya, biasanya kan kita pakai Bunsen burner. Let's say our Bunsen burner contain propane. And then we try to boil a water, which is how many gram of water? 50 gram of water. We assume that system ni adalah isolated. All the heat released from the combustion of propane will transfer to water. That is our assumption. And the water will absorb the heat so that the thermometer will increase. The thermometer reading akan bertambah. So this is the analogy. We assume that all the heat released from the combustion of propane absorbed by water. So how to write the statement yang kita kata, yang soalan tu? State the assumption made in your calculation. So our assumption is the heat released from the combustion of propane is absorbed by water, or was absorbed by water. So that is the assumption. Okay, so maybe you can write the assumption. Saya malas nak type sebenarnya. Heat. Saya confirm. Heat release from combustion of is kenapa? Because this is an isolated system. Okay. So how to perform a calculation? So this is our assumption, because ada soalan yang assumption. So macam mana kita nak kira? Do you have, okay, now let's look at the information. So we already have the mass of the water and the initial temperature. Remember, it is boil. Okay, so we also have this one, delta HC propane, which is a standard enthalpy of combustion. So how to solve the problem? Okay, so kita punya, based on the assumption, kita boleh tulis heat of the reaction, which is the combustion of propane, heat release, akan diserap oleh water. Dia tak cakap kan duduk dalam kalorimeter ke apa. Okay, now. Heat yang daripada water adalah M water, C water, delta T. We know that it is given 50 gram and the sea water is constant 4.18 joule per gram per degree Celsius. And what about delta T? Okay, to boil a water, which means 100 minus 30, which is the initial temperature. So the temperature will cancel off, the mass and the mass will cancel off, so that you will get 14630 joule, which is negative 14630 joule. Or you can transform to kilojoule, which is 14.63 kilojoule. So soalan nak apa? Calculate the mass of propane required. So okay. So yang ini kita tak tahu datang daripada berapa mol propane. Okay. So yang kita tahu confirm adalah 1 mol. So kita akan further calculate 1 mole propane combusted produce negative 220.1 kilojoule. How many mole of propane if it release 14.63 kilojoule? Okay, negative only indicate that the heat was released. So you tak payah letak negative pun tak apa. Okay, supaya nanti takut awak tersalah dalam calculation. Okay, now you already get this. And then you nak letak apa? Cari mol. Berapa mol? Okay, I get 14.63 bahagi 14.63 bahagi 220.1. 0.06 6. Okay, I get this. And then dia nak mass. Okay, barulah kita pakai formula mass sama dengan mol darab molar mass, which is 0.0665 mol times 44 gram per mol. So mol will cancel off. 0.0665 times 44, 2.93. This is the mass of propane required to boil a water. Okay, alright. So this is how we try to answer question number 1. Okay, so why don't we look at question number 2? We will look at another example. For those who try to answer the question, you can check the answer. Okay, now let's look at number 2. Okay, apa benda number 2 ni dia cakap apa? A thermochemical equation, write the thermochemical equation that represent the enthalpy of combustion for aluminium metal if the reaction of 0.25 mole aluminium produce 419 kilojoule. Okay, so this is the enthalpy of combustion punya value. It's supposed to be negative. And then you need to determine the enthalpy of, is it this one, question number 2? Oh, I answer question number 3 dulu. Nanti saya potong balik, saya dah terbuka ni, biarlah. Okay, and then determine the enthalpy of formation of aluminium oxide and write its thermochemical equation. Okay, now ada dua perkara kat dalam soalan ni. Firstly, dia minta ataupun dia bagi sedikit info untuk enthalpy of combustion aluminium. But then dia suruh cari enthalpy of formation aluminium oxide. So what is the relation between these two? Okay, so dia bagi combustion aluminium, kita buat dulu equation untuk combustion aluminium. Aluminium solid combusted in excess oxygen will produce aluminium oxide. Okay, how to balance the equation? We need 1 mole and we have 2 mole here. So we can put half. But we only need 3/2. So ini adalah 3/4 O2. And then this is delta HC aluminium that is negative 419 kilojoule. Okay, equation, jangan tulis kilojoule per mole because we already understood it is 1 mole based on the balance equation. Okay, now dia kata yang terbakar hanya, oh sorry, belum lagi, tak tahu lagi nilai enthalpy tak tahu lagi. Sebab 419 ni adalah untuk 0.25 mol kan. Okay, kita dah ada balance equation. And then baru kita boleh tulis 0.25 mole aluminium equivalent to ataupun release negative 419 kilojoule. If 1 mole aluminium, berapa joule yang dia bebaskan? Empat 119 25 1676 negatif 1676 kilojoule per mole lah kan, sebab 1 mole. So kat sini delta HC kita adalah negatif 1676 kilojoule. Baru betul jawapan kita. Okay, sebab 419 tu adalah untuk 0.25. Tapi kalau thermochemical equation, dia mesti untuk 1 mole. Okay. And then kita nak jawab enthalpy of formation aluminium oxide. Based on the definition, the enthalpy of formation aluminium oxide means 1 mole of aluminium oxide formed. from its element. Elemen dia adalah aluminium. Tak semestinya 1 mole 2 mole aluminium plus 3/2 mole oxygen. So berapa pula dia punya delta HF? So now let's look at these two. What is the relation? If we can see, the enthalpy of formation ni adalah sekali ganda atau darab 2 daripada delta HC. So kita boleh tulis statement delta HF Al2O3 sama dengan 2 times delta HC aluminium. So that you can get 2 times 1676 kilojoule. Okay, you will get negative 3352 kilojoule per mole because it is for the enthalpy of formation. So now you can put the answer delta HF is equal to negative 3352 kilojoule. Okay, kita boleh terima dia sebagai negatif because the enthalpy of formation adalah heat change. It can be positive or negative. Is that okay? Okay. Kita tak ada siapa pun. Alright, so this is the answer for number 2. Let me see number this one. Okay. Okay. A combustion of 1 mole butane gas involves 2874 kilojoule of heat. This is one information. 1 mole butane sama dengan itu. Write the thermochemical equation for the combustion of butane. Okay, dia nak kita buat thermochemical equation. This is for the first one. Okay, so kita kata nombor 1, kita kenalah tulis butane. C4H10 gas, dia dah sebut gas, kita ikut dia. Tambah O2 gas menghasilkan CO2 gas tambah H2O liquid. Okay, so this is 4 mole, this is 5 mole, and then 4 kali 2, 8 tambah 5. Tambah 5 berapa? 8 tambah 5, 13. 13 per 2. And the delta HC, negative, don't forget to put a negative sign, 2874 kilojoule. Okay. Thermochemical equation tu boleh lah kan? Okay. Calculate the mass of butane that must be burned in order to increase 1.56 degrees Celsius of 100 gram of water in a bomb calorimeter with the specific heat 958 joule per degree Celsius. We have a lot of information, so kita kena suitkan yang mana satu nak pakai. Kita nak, this is the delta T, we have 100 gram of water and also the information for bomb calorimeter. Meaning that we cannot ignore the bomb calorimeter punya value. Okay, in this case. Alright, so macam mana cerita ni? Calculate the mass of water must be burned. Dia konsep dia macam tadilah. What we call it? Butane dipanaskan, haba yang dibebaskan daripada pemanasan butane digunakan untuk ataupun telah menaikkan suhu air. Okay, dan air itu pula duduk dalam calorimeter. So we need to consider both. So kita boleh tulis Q reaction which is daripada pemanasan butane is equal to heat absorbed by water plus heat absorbed by calorimeter. In this case, we cannot ignore the calorimeter. Okay, now, what about water? We already have the mass of the water. C water is a constant and delta T. While, remember, on the joule per degree Celsius, so we use C calorimeter delta T. So we use that formula. Okay, so macam mana nak buat? Then mass of water we already have 100 or 1000. 1000 banyaknya. 1 liter lah ni. 1000 gram times 4.18 kilojoule per gram per degree Celsius darab 1.56 tambah 958 darab 1.56. Okay, unit tu, oh yang ni saya tak letak unit dah pula. Saya joule per degree Celsius darab okey, apa you dapat? Saya dapat 8015.28 joule. So saya convert jadi 8.015 kilojoule. Okay. Alright. Okay. So it is given in a question. Dia kata, ni kan dia dah bagi kat kita enthalpy of ni kan. Okay, so kita nak tahu berapa berat kan. Dan kita tulis 1 mole butane release, combusted, release negative 2874 kilojoule. Berapa mol butane kalau membebaskan 8.015 kilojoule? Because as I mentioned previously, ni adalah hanya magnitude heat release, so tak payah. How many mole? I get 2.78 times 10 to the power of negative 3 mole. Am I right? Okay. And then, carilah mass. Macam biasa, mass sama dengan mole times molar mass 0.162 gram. So this is the mass of the butane required to increase the temperature. Okay, yang last tu. Write the draw the energy profile diagram for the reaction. We know that combustion is an exothermic reaction because it releases energy. Okay, so this is the reaction progress or pathway. This is the enthalpy. Okay, asal dia mesti tinggi menjadi rendah because they release the energy. Okay, siapa yang duduk kat atas ni? It is C4H10 gas plus 13/2 oxygen. 4 CO2 gas plus 5 water. Okay, so this is how we write. Okay, tak lengkap lagi ni. We need to label the enthalpy. This is the enthalpy. Delta H adalah perbezaan daripada reaktan ke produk. Enthalpy dia sebanyak berapa? Untuk 1 mol. Negatif 2874 kilojoule. Okay, ini delta H. Biasanya dia buat untuk 1 mol lah. Okay. Saya dah tunjuk jawapan untuk nombor 1, nombor 2, nombor 3. Okay. Right. Siapa yang dah buat? Okay. Nombor 4, soalan dia lebih kurang sama je. Dia minta state assumption. Cuma dia nak final temperature. Okay. Cara penyelesaian dia hampir sama. So, siapa yang dah buat nombor 4, boleh bagi tahu kat saya dan nanti saya akan bagi jawapan T final dia berapa. Okay, saya nak tengok you all buat. Dan juga nombor 5 yang dekat belakang tu, which is the enthalpy of neutralization. Okay, itu pun saya dah tunjuk contoh dalam yang petang semalam. So, hopefully you all boleh cuba yang itu. So, yang neutralization ni kita nak buat. Okay. Saya dah tunjuk 3 ni sebab yang ni dia macam tak ada dalam contoh semalam. That's why saya tunjuk. Okay. Okay. Sekejap. Saya rasa nombor ni saya tunjuk lah. Sekejap ya. Tutup lah. Saya tunjuklah enthalpy of neutralization tu. Saya takut ada yang tak tengok. Yang semalam termiss kelas untuk neutralization ni. Okey, untuk neutralization ni dia minta apa? State the assumption. Okay, as usual lah. Okay, the reaction is between. Okay, tulisan kat situ boleh nampak. Okay, let me enlarge the font. Okay. So the reaction is between acetic acid and the sodium hydroxide. We know that acetic acid is a weak acid dan sodium hydroxide is a strong base. Okay, dia ada dua kat sini. Kalau dia adalah strong acid, strong base, maknanya HCl dengan sodium hydroxide, for example, you punya enthalpy theoretically adalah 57.7. Tapi kalau salah satu tu weak, the value can be less than 57. 57 tu adalah theoretical enthalpy of neutralization between strong acid, strong base. Itu you all kena tahu. Dalam nota pun dah ada bagi tahu kan. So dalam kes ni dia adalah strong and weak. So it can be less than 57 lah. Alright, so first of all, state the assumption. So kita as usual, assumption tu adalah heat release from the reaction that represent the neutralization Q reaction, in this case adalah neutralization, is equal to heat absorbed by water plus calorimeter. Because we don't have any information related to the calorimeter, so kita terus kata heat released from the reaction is equal to the heat absorbed by water. So that is our assumption. Okay, transform into a diagram tak payahlah. Tak kena mengena pun. Okay, and then next, because neutralization refer to the amount ataupun to the mole of water form, we need to have a balanced chemical equation. So mesti tulis. Okay. Then kita ada info. Yang ini 30 ml 1.0 molar. Ini 20 Allahu Akbar ml 2.0 molar. Okay. Remember, kita kena tengok pada air, bukan pada mole acid or mole base. Now we have the information untuk dua-dua reaktan yang terlibat. So kita hanya boleh bandingkan mole. We cannot compare the others. So this is 0.03 mole. This is 0.04 mole. So because of that, kita boleh buat assumption or a statement. Kita kata, siapa yang kecil? 0.03. So therefore 0.03 mole of water produced from this reaction. Statement ini penting. Kenapa? Because acetic acid is a limiting reactant. Okay. Alright, now barulah kita balik kepada kita punya assumption yang asal-asal. Q reaction, which is the neutralization, is equal to heat absorbed by water plus heat absorbed by calorimeter. Since we don't have the information for the calorimeter, kita boleh buat, okay, mana nak dapat mass of water? We know that when we combine this, kita akan dapat 50 ml of water. Density of water is equal to 1. So kalau 50 ml, dapatlah juga 50 gram. Darab 4.18 darab apa? Delta T. Dia 28 kan? 28 tolak 25. Okay, jadi berapa ni? 627 saya dapat. Okay, saya dapat 627 joule. So, kalau nak tukar jadi kilojoule, 0.627 kilojoule. Don't forget to put a negative sebab dia adalah neutralization yang membebaskan haba. So that we can put a statement 0.03 mole water form equivalent to negative 0.637 kilojoule. Kalau 1 mole of water sama dengan berapa? Saya dapat negative 20.9 kilojoule per mole. So, you boleh tulis delta H neutralization negative 20.9 kilojoule per mole. Kenapa dia boleh dapat rendah daripada 55.57 tu? Because it is a weak acid and strong base. Macam tu cara dia. Okay, so I think that's all for today. You can try to answer the others question. Okay, kita jumpa lagi esok untuk kelas macam biasa. Okay, so selamat berbuka puasa. Kalau ada masalah boleh terus tanya saya dekat Telegram.